Example problem number 3. Hockey puck travels a displacement of 4.2 meters south 38 degrees west and is then struck by a hockey player's stick and undergoes a displacement of 2.7 meters east 25 degrees north. What is the puck's total displacement? So we're going to start off with the first vector. The first vector, and you should probably highlight this in your question, is 4.2 meters south 38 degrees west. So again, that's made out of two vectors. We have a south component, and then we also have a west component. So again, it's just a sketch, you're just trying to get an outline. So then we have a resultant vector of those two, and that is what's being shown in this one right here. So we know that this here is 38 degrees. Right, that's that angle. And then we also know that this is 4.2 meters. So we've gone south and then west. So that first motion is going to end up over here somewhere. Then, again, we're going to solve this through the algebraic method. So then we're going to start off at the origin again, and we're going to draw a second triangle that shows the second component of the question. The second triangle is now 2.7 meters east, 25 degrees north. So, second vector, we are going east, and then we're also going a little bit north. In this case, we are going 25 degrees. So this angle here is 25 degrees. And then we know the vector here is going to be 2.7 meters. So again, two triangles showing the two individual displacements, but what we're going to do is take these triangles and sum the vectors, and so we're going to sum the x and sum the y. So we're going to start off with the y. Again, this is our y component. So this is going to be our north, south component. And again, we're going to define these. So we're going to have this as triangle 1, this as triangle 2. So we're going to look at calculating triangle 1 first. So again, we are now looking at figuring out really now the north, or the sum of the north. And so we're going to take a look at triangle number 1 first. Alright, number 1, we're looking at trying to figure out our y. So again, this is our adjacent in relation to our angle. So this is adjacent over hypotenuse, so that's the cosine. So we're looking at cosine of 38 degrees equals x over 4.2. And so in this case, our x is going to equal 3.016 meters, and that is going to be south. We're going to do the same thing for triangle number 2. So we're looking at trying to figure out the y component there. So that one's now going to be opposite over hypotenuse. So that's going to be the sine of 25 degrees. So sine 25 degrees equals x over 2.7 x is then going to equal 1.141 meters, and that's going to be north. Now, if we take a look at those, we now have two different directions. Again, just like we did for kinematic word problems, we have to make sure those directions are the same. So now we're going to have to change the sign of one of them. So I'm going to take this and I'm going to rewrite that. So I'm going to get the sum of y is going to equal 3.016 meters plus, because it's the sum, I'm going to make this one negative 1.141 to make it south. Right? So this right now is 1.141 meters north. In order to make it south, I have to make it negative 1.41 meters north, which means it's going the opposite way. So again, we should say the sum, we're summing the vectors. So then that is going to equal 2.1686 meters south. Alright, so now we're going to do the same thing for our x component. And our x component is dealing with east-west. So again, we're going to start off with triangle number 1. Now we're concerned about this vector, and in triangle 2 we're concerned about this vector. And so in triangle number 1, we are now going opposite over hypotenuse. So it's going to be the sine of 38 equals x over 4.2. X is going to equal 2.5858 meters. In this case, that's west. We're now going to look at triangle number 2. And now we're going east. So, and again, in that triangle, we are looking at, now this one here is going to be adjacent, and that's going to be over hypotenuse, so that's going to be the cosine. So it's the cosine of 25 degrees equals x over 2.7. And then x is going to now equal 2.447 meters. And that is now going east. Once again, we have the same situation. We're now going opposite directions. So we need to make them both west or both east. And again, I always take the lower number, so because I know it's going to end up west here. So in order to make this one west, it has to be negative 2.447 meters. And then again, I call that east. But then that negative indicates that it's going the opposite way. So now I can take the sum of x, which is going to be now 2.5858 plus negative 2.447 447, and that is going to equal 0.1388 meters, and again that is going to be overall east. Sorry, not east, that should be west. It's a positive number, so it should be west. Alright, so we now have two components here. So we got our south component and we got our west component. So now we can take a look at putting this information on our triangle. So again, our triangle, we have a west component of 0.1388, and then we have a south component of 2.1686. So we really have our south component 2.1686 meters, and then we have our west component, which is 0.1388, and we are trying to find our hypotenuse, and we're also trying to find our angle. So I'm going to let you try to figure that out yourself. Again, we're using Pythagorean theorem, and then we are also going to use trigonometry to figure out that angle. And so you know if you're doing it right because your final answer should be 2.2 meters west, 86 degrees south. So that would be your final answer for that question. Again, the 2.2 would come from the Pythagorean theorem. The west 86 degrees south would come from your trigonometry. All right, so now you're set up to tackle some of these questions. For homework, all I want you to do is really review these videos again and just kind of get the idea of what you have to do for your questions, and then I will post maybe one or two questions that you want to try for your homework just for some practice, and then we will review this concept again when you come back after your unit test, which is the next day.